Do you want to make your own IoT projects? I'm an IoT product developer and I'm going to show you exactly how to do that. If you stay till the end of the video, I'm going to show you how this little development board can help you make your IoT projects quickly and easily.
Before we proceed, don't forget to subscribe to our channel to catch more of our tutorials and content. Also check out the links to this blog article and related GitHub repositories in the description below.
For Wi-Fi projects, I strongly recommend using the ESP8266. This is a system on a chip that provides the capabilities of a processor, GPIOs and Wi-Fi in a single package. I use the ESP12E version and the ESP12E NodeMCU development board for my projects. The NodeMCU is a very convenient way for developers to interface with the ESP12E system. It provides a USB interface for programming and serial communication to the board, an on-board voltage regulation circuit so it can be safely powered by USB, several on-board GPIO pins with two internally connected LEDs controlled by pins D4 and D0, dedicated pins for UART serial communication, SPI and I2C, a built-in reset button. The ESP8266 is sturdy and stable and allows for quick development as well as deployment in production environments. Most importantly, the NodeMCU is extremely affordable. There is plenty of support for the ESP8266 and NodeMCU online with thousands of developers and hundreds of libraries that can help you build applications as per your requirement. There is a huge community that has tried and tested it for a few years and contributed greatly to its stability. The best part is that it is Arduino compatible. You can use this to program Wi-Fi applications just like you program a regular Arduino Uno. To be able to use the Arduino software to program this, all you need to do is follow these steps. Step 1. Download and install the Arduino IDE. Simply navigate to the arduino.cc website. Here, hover on the software menu and click on download. Based on your operating system, download the install file. For Windows, I am downloading the latest Windows installer. Once the download completes, open the installer to install the Arduino IDE software on your PC. Follow through the process and soon you will have the Arduino IDE application installed. You will see an icon on your desktop as well. Step 2. Install the ESP8266 NodeMCU boards for the Arduino IDE. With this, the IDE can recognize the NodeMCU when it is plugged in. For this step, you will require a link which is available on our blog. You can navigate to our blog and open the article called Getting Started with the ESP8266 NodeMCU. Now, open the Arduino IDE and navigate to File and click on Preferences. In the Preferences, you will see a section called Additional Board Manager URLs. Here, you need to paste the link provided in the blog article. This is the link that ends in .json. You can simply copy this line and paste it here. You can now click OK. Once this is done, navigate to Tools, Boards and open the Board Manager. Scroll down until you find a listing called ESP8266 by the ESP8266 Community. Click on it and select Install. This will install the ESP8266 board for your Arduino IDE. This might take a minute. Once it finishes installing, you will see it marked as installed. On restarting the IDE, navigate to Tools and open Boards. In this list, you will now see some ESP8266 and NodeMCU boards listed. This means that the ESP8266 boards were successfully installed. Now, to program the NodeMCU, all you need to do is write your sketch, select the board as NodeMCU 1.0 and upload your sketch. Step 3. Install some libraries to help you run Wi-Fi functions on the ESP8266 NodeMCU sketches. To do this, open your browser and navigate to the ESP Core GitHub repository. You can find the link on our blog article. In this repository, you will find the ESP Core for Arduino. Here, click on Clone or Download and select Download Zip. Once the zip file downloads, extract it. On extracting it, you will find a folder called Libraries inside it. Open this folder, select all the contents, right-click and click Copy. Now, open the location of your Arduino IDE installation. For Windows, this is usually located in C drive, Program Files x86, Arduino. Here you will see another folder called Libraries. Paste the copied files into this folder. Once that is done, you can restart the Arduino IDE software. Now you are ready to start programming the NodeMCU. Let us write our first program on the ESP8266. To do this, we open the Arduino IDE, select Tools and select the board as NodeMCU 1.0 ESP12E module. I am going to use this NodeMCU mini kit, which is basically a NodeMCU with a USB mini cable. We plug in one end of the USB cable into the NodeMCU and the other end into the USB of your PC. On plugging it in, the Arduino IDE will automatically detect the NodeMCU. This can be confirmed by checking a valid entry under Ports in the Tools menu. Now we can start to code. We are going to run an LED blink sketch as our first NodeMCU program. To do this, we will make use of the inbuilt LED on pin D4 of the NodeMCU. We first define pin D4 as an output pin, since we are going to use it for the LED control. In the loop function, we turn it on and off with a 500 millisecond delay in between. This program expects the LED at pin D4 to continuously blink every second. Cross-check your board and port selections from the Tools menu. To program the NodeMCU with this sketch, click on the Upload button on the top bar of the Arduino IDE. On doing so, the program will first compile and then flash to the NodeMCU. Be patient. This might take up to 1 minute. The program has finished flashing to the NodeMCU and the LED immediately starts blinking as expected. So this was your first NodeMCU program. Well done. Now let's take a step further and write a sketch to connect the NodeMCU to your Wi-Fi network. Let's write a sketch that will make the LEDs blink only after the NodeMCU has successfully connected to your Wi-Fi network. To do this, we will make use of one of the Arduino core libraries. We will add a Wi-Fi connection function in the setup section of this code with the name and password of your Wi-Fi network. I am going to program it to connect to my mobile hotspot. To do this, I will first start my mobile hotspot. Then, I put in the Wi-Fi network details accordingly into the NodeMCU program. In the setup function, we also add a while loop that exits only when the Wi-Fi is successfully connected. This is to wait for the NodeMCU to connect to the Wi-Fi network successfully. The loop function stays the same. This will execute only after the setup function has successfully finished executing. Now, we also add some serial messages so that the NodeMCU sends a message to the PC when it connects to the Wi-Fi. Now, this is all set up. Let's upload the sketch. As expected, there is a small delay before the LEDs start blinking. This is the time taken by the NodeMCU to connect to the Wi-Fi network. Now, let's reset the NodeMCU and check the serial messages on the Arduino IDE's serial monitor. To do that, simply click on the serial monitor icon on the Arduino IDE and make sure that the baud rate is the same as defined in the serial.begin function in the code. Now, we press the reset button to restart the NodeMCU and monitor its execution. The messages are visible on the serial monitor and the LED blinks as expected. We can also check on the mobile hotspot interface, and we can confirm that the ESP8266 has successfully connected to the mobile hotspot. Congrats! You just connected your IoT device to a Wi-Fi network.
So, to recap, this video showed you how to get started with the NodeMCU and write your first sketch. And now that you've got your first NodeMCU sketch up, I'm sure you're wondering how you can get the NodeMCU to actually connect to the internet and surf your favorite websites. Well, you can do that by following my blog article, and the link for that is in the description below. I've also compiled a great kit, a great beginner's kit for all you beginners out there. That kit is available in the description below also. The link is out there and it's specially made for these projects. I hope you make something really awesome and convert your ideas into reality.